Hello, everyone. Welcome to today's session on reasoning classes, Part 2, focusing on intermediate topics. I'm excited to guide you through this journey. The book is written by Varun Vijay, specifically tailored for aspirants preparing for SSC, bank, railway, BPSC, and UPSC exams. In this presentation, we'll master new reasoning patterns using effective tricks and plenty of practice. So let's get started and enhance our reasoning skills together. Let's begin with a quick summary of what we've covered so far and what's coming up next. First, we explored direction sense, which helps us understand and identify directions accurately. Then, we looked into ranking and order, focusing on how to determine positions in various sequences. After that, we discussed sitting arrangement, which is all about arranging people or objects logically and efficiently. We also touched upon mathematical reasoning, an essential skill that involves solving problems using math concepts. Now, before we move forward, I'll give you a mini revision of these topics to reinforce your understanding. Plus, I'll give you a sneak peek into the next part of our course so you're prepared. Our main goal throughout this session is to help you understand each concept thoroughly, introduce you to shortcut tricks that save time, go through relevant examples, and provide practice questions to strengthen your skills. Remember, the book we're following is by Varun Vijay, which is a great resource for these topics. So keep focused, and let's continue building your problem-solving abilities step by step. Let's dive into the concept of direction sense and some useful tricks to master it. First, there are the four main directions: north, east, south, and west. These are the primary points we use to navigate. In addition to these, there are four intermediate directions: northeast, southeast, southwest, and northwest, which help us pinpoint directions more precisely. Now, when it comes to turning rules, it's pretty straightforward. Turning right means rotating clockwise by 90 degrees, while turning left means rotating anti-clockwise by 90 degrees. These rules are fundamental when you're figuring out directions after turns. Here's a helpful trick to simplify the process. Start by taking your starting point as the origin on a coordinate plane. Draw an arrow in the initial direction you're facing, then use that as a reference to track your movement. This visual approach makes understanding your position much easier. And when you want to find the shortest distance between 2 points, there's a simple formula: the square root of the sum of the squares of the x and y displacements. Basically, it's the Pythagorean theorem. If you know how far you've moved horizontally and vertically, you can quickly calculate the shortest straight line distance. This concept ties into the overall theme of direction sense by helping us visualize and calculate movements accurately, whether in navigation puzzles or real-life scenarios. Remember, mastering these basics makes solving related problems much more intuitive. Let's look at this example to understand direction sense better. Ramesh walks 3 kilometers to the north, then turns and walks 4 kilometers to the east. To find the straight line distance from his starting point, we use the Pythagorean theorem, the square root of 3 squared plus 4 squared, which equals 5 kilometers. And since he's northeast of his starting point, we say his direction is NE. Now let's try some practice problems. First, a walks 4 meters north, then turns and walks 3 meters east. To find A's overall direction from the start, we need to consider the net movement. Think of it as a right-angled triangle again, and we can find the resultant direction from the starting point. Next, B walks 5 meters south, then 5 meters west, and finally 5 meters north. What's B's position relative to the start? Again, we analyze each move step by step, keeping track of the net displacement in both directions. And finally, imagine 2 people facing each other. One turns left and the other turns right. After these turns, which direction are they now facing? It's a good way to understand how turning changes our orientation. Remember, these exercises help us develop a good sense of direction and distance, which are key concepts in understanding spatial relationships. Keep practicing, and you'll find it becoming second nature. All right, let's dive into the concept of ranking and order. So the main idea here is that if you take a person's position from the top and add it to their position from the bottom, you'll get a total that's always one more than the actual number of people. For example, if someone is third from the top and there are 10 people in total, then their position from the bottom would be 8, because 10 minus 3 plus 1 equals 8. When you add 3 and 8, you get 11, which is 1 more than 10. Now, a key trick here is to remember that we can use the same formula separately for boys and girls. This helps us analyze their rankings independently without mixing the two groups, which can be very useful in certain problems. I've also drawn a diagram to clarify a common confusion: left versus right. Sometimes, when you're dealing with positions or directions, it's easy to get mixed up. The diagram shows how to clearly distinguish between these, so you don't mix up the left side and right side when solving these types of problems. This concept of ranking, and the trick with the same formula for boys and girls, really ties into the overall theme of understanding order and position in a logical, structured way. It's a fundamental idea that comes up often, so mastering it will definitely help you in many problem-solving scenarios. Let's take a look at an example to understand the concept of ranking and order. Suppose A is 5th from the top and 10th from the bottom. To find the total number of students, we add these two positions and subtract 1, because we are counting it twice. So, 5 plus 10 minus 1 gives us a total of 14 students. This example helps us see how the positions from the top and bottom relate to the total number of students. Now, let's move on to some practice problems to reinforce this idea. First, imagine a row of 40 students, and Ravi is 12th from the left. To find his position from the right, we subtract Ravi's position from the total number of students and add 1. So 40 minus 12 plus 1 equals 29. Therefore, Ravi is 29th from the right. Next, consider two students. A and B. A is ranked 6th from the top, and B is ranked 8th from the bottom, in a class of 20 students. To find out how many students are between A and B, we need to find their positions from the same side and then subtract. A's position from the top is 6, and B's from the bottom is 8. Since the total is 20, B's position from the top is 20 minus 8 plus 1, which equals 13. Now, the number of students between A and B is 13 minus 6 minus 1, which equals 6. Finally, let's look at a case involving Anita. She is 15th from the top, and the total number of students is 30. To find her rank from the bottom, we subtract her position from the top from the total, and then add 1. So 30 minus 15 plus 1 equals 16. That means Anita is 16th from the bottom. These examples and practice problems highlight how understanding the positions from the top and bottom can help us determine the total number of students and the relative positions within the group. Keep practicing these concepts, and you'll master ranking and order in no time. All right, let's talk about sitting arrangements, specifically the concepts and tricks involved. When we compare linear and circular arrangements, the key difference really comes down to facing direction. In a linear setup, everyone faces the same way, usually straight ahead. But in a circular arrangement, people are facing towards the center or outwards, and that affects how we interpret left and right. Now, if everyone is facing the center, then turning left is actually moving anti-clockwise around the circle. But if they're facing outward, then turning left is clockwise. It's a small detail, but it makes a big difference in how groups are perceived and how conversations flow. Here's a handy trick. Fix one person's position first. Once you establish that anchor point, you can then arrange everyone else relative to that person. This makes organizing the seating much simpler and ensures consistency, especially when managing larger groups or complex setups. So, in essence, understanding these directional cues and using the fixed point trick can greatly improve how we plan and execute seating arrangements, which ties back to our overall theme of effective communication and coordination. Now, let's look at an example of sitting arrangements. Imagine 5 people sitting in a circle. If we know that A is to the right of B and C is to the left of D, the challenge is to find who sits between A and C. This kind of problem helps us understand relative positions and develop our logical thinking. Moving on to practice questions, these are designed to sharpen your skills. First, picture 6 friends sitting in a row. We know that A is to the left of B, but to the right of C. The question is, who is sitting in the middle? Think about how the positions relate to each other. Next, consider a circle of 8 people facing the center. R is positioned as the third person to the right of P. The question is, who is the second person to the left of R? Visualizing the circle and counting positions is key here. Finally, imagine P and Q are facing each other. If both of them turn to their right, the question is, which direction are they now facing? This helps us understand how turning affects directionality. These exercises are excellent for practicing how to analyze sitting arrangements, which is a common type of reasoning question. They test our ability to visualize positions and directions, which is essential for many logical reasoning problems. Let's talk about mathematical reasoning, specifically the concept and a useful trick to make solving these problems easier. When dealing with expressions, always remember to follow the BODMAS rule carefully. This means handling brackets, orders, division, multiplication, addition, and subtraction in the correct sequence. It's crucial to stay disciplined with this order to arrive at the right answer. Now, an interesting twist is to assume that the symbols, like plus and minus or multiplication and division, might be interchanged. This can actually help you understand the problem better and avoid common mistakes. Here's the trick I want to share. First, replace the symbols with their interchanged counterparts. So, switch plus with minus and multiply with divide, for example. Once you've done that, then proceed step by step, calculating the expression carefully. This approach often clarifies the problem and helps prevent errors that come from misreading the symbols. Remember, the key is to replace the symbols first, then evaluate, following the proper order of operations. This method simplifies complex problems and sharpens your mathematical reasoning skills. And by practicing this trick, you'll become more confident in tackling tricky expressions, which ties back to our overall goal of strengthening logical thinking and problem-solving abilities. This technique, shared by book writer Varun Vijay, is a handy tool in our mathematical toolkit. Let's look at an example of mathematical reasoning. Suppose we have a tricky situation where the symbols are not what they seem. If times actually means plus, and plus means, how would we solve 2 plus 3 times 4? Well, replacing the symbols, it becomes 2, 3 plus 4, which equals 3. This example highlights how important it is to understand the meaning behind symbols before solving problems. Now, moving on to practice, here are some exercises to sharpen our reasoning skills. First, if it means times and times means plus, what is 6 times 3? 2. Think about it carefully. Substituting the symbols, it becomes 6 plus 3 times 2, which we then evaluate accordingly. Next, let's try to find the missing number in a sequence of equations. 5 plus 3 equals 28, and 7 plus 2 equals 63. What about 8 plus 4? Notice these patterns might not be straightforward, so we need to think creatively here. Finally, there's a simple substitution problem. If A equals 1 and B equals 2, what is the value of AB plus BA? Remember, these are just variables representing numbers, so AB means A times B, and BA is B times A, which are the same. So adding them up gives us a good chance to practice our understanding of variables and their values. All these examples and exercises are designed to develop our reasoning, especially when symbols or numbers don't follow the usual rules. Keep practicing, and you'll become more confident in tackling complex problems. Let's do a quick mini revision to reinforce what we've learned. First, when drawing diagrams, remember the NE rule, which helps us visualize problems clearly. For ranking questions, the key is to understand that top plus bottom equals total plus 1. That's a simple yet powerful rule to solve such questions efficiently. When deciding sitting arrangements, always start by choosing the facing direction first, as it sets the foundation for solving the rest of the problem. Moving on to math reasoning, replace symbols with their values and apply BODMAS carefully. This ensures your calculations are correct and logical. And finally, a very important tip: practice reasoning daily. Patterns tend to repeat in exams, and Varun Vijay, the author of our book, emphasizes this. Regular practice sharpens your mind and makes these concepts second nature during the exam. Keep these points in mind, and you'll see your problem-solving skills improve steadily. Now, let's take a quick look at what's coming up next in our series. In Part 3, we'll explore some fascinating topics that will sharpen your reasoning skills even further. First, we'll dive into syllogism and statement, conclusion exercises, which are great for developing logical thinking and understanding how conclusions are derived from given statements. Then, we'll move on to calendar and clock problems, helping you improve your ability to interpret time and dates, an essential skill in many reasoning tests. Next, we'll challenge ourselves with puzzle and mixed reasoning questions, which are perfect for boosting your problem-solving agility and adaptability. And to keep the learning momentum going, I'll introduce you to the book writer, Varun Vijay, who's authored resources to help you deepen your understanding. Remember, each of these topics builds on what we've already learned, so stay engaged and ready to apply these concepts practically. We're on a continuous journey of learning and improvement, and I look forward to exploring these exciting areas with you.